to discuss about the proof of dq is equals to du plus dw. From the first law of thermodynamics, we can write an equation dq is equals to dE plus pdv. But we know that the total energy is equals to kinetic energy plus potential energy and internal energy, whereas the kinetic energy and potential energy comes under macroscopic approach and internal energy comes under microscopic approach. The difference between macroscopic approach and microscopic approach is, if the behavior of individual molecule is taken into consideration, then it is known as microscopic approach. If the average behavior of number of molecules is taken into consideration, then it is known as macroscopic approach. This microscopic approach is also known as statistical thermodynamics, and macroscopic approach is also known as classical thermodynamics. We can prove dq is equals to du plus dw by taking the following example. Consider a piston and cylinder arrangement. When the piston is at state number 1, the kinetic energy possessed by the system is 0. Why? Because initially it is at rest condition, therefore initial kinetic energy is equals to 0. When it occupies the second position, then the kinetic energy at state 2 is also 0. Therefore there is no change in its kinetic energy. As the system is located at equal elevations, that is Z1 and Z2, there is no change in its potential energy. Therefore change in its potential energy is equals to 0 and kinetic energy is also 0. Therefore total energy becomes kinetic energy plus potential energy plus internal energy becomes A is equals to U. Energy is equals to internal energy. If you differentiate on both sides, dE is equals to du. Now replace this dE with du in the equation from first law of thermodynamics. That is, dq is equals to du plus pdv. That is equals to dq is equals to du plus dw. This is the equation applicable for reversible process.